Good morning, good evening, whoever you are, wherever you are, whatever you might be doing. We wish to welcome you to the Silverlight Show. The Silverlight shines to illuminate that which lies hidden in darkness. For those of you tuning in today, we welcome you in. One of the things I like to study is time. After all, time goes differently for all of us. We, we've even measured it. If you take a child who is maybe 5 to 10 years old, they feel that years are longer because their experience, 1 year is, say, 1/5 of their life. Whereas to a 64-year-old, that 1 year is 1/64 of their life. It seems to go quicker because of the experience. Now, this is relevant because in logical physics, which is where a lot of people like to do their experiments, since we're we are beings of time, we're not beings that can control time. We are three-dimensional creatures, not fourth, given time as the fourth dimension according to classical Einstein theory. Now, the interesting thing is, in an article from phys.org, how logic alone may prove time does not exist, they assert time is ultimately a measure of change, even according to physics. It is often identified as a rise in disorder, also known as entropy, of a closed system. Take a cup of coffee. As it cools down, entropy rises. And you can tell roughly how long a cup of coffee has been standing there by its temperature. Any device that measures time, such as a clock, relies on change, ticks. And this is where I feel the ultimate proof for time actually comes. Chemical reactions are happening constantly. They don't require us to be observing. They don't require any particular observer. Maybe there's aliens everywhere. Maybe, spiritual beings have a job to do nothing but to watch and make sure time progresses. But that would still imply time was happening. Again, from our perspective, time is essential. And mathematically, we can model a universe without time. That's perfectly fine. We can also model a video game that has dragons and fairies and orcs and everything, which do not exist but still exist within that environment. So while mathematical models are highly useful for studying things, they're not the be all end all in explanations. There's a lot of things that go on in the background. Let's take the Jupiter's moon Io. We know chemical reactions are happening there all the time. And probably a great deal of them as volcanoes are spewing forth lava. The flux tube is constantly changing, getting more or less magnetic. We've been able to measure this stuff happening. Even back in the 70s when the Voyagers went by, would that be the 80s? I think that would be the early 80s. When the Voyagers went by, they were able to measure it, and they were not dealing with a static system. They were working with an evolving system that was moving forward in time. Chemical reactions were taking place, and when it left, they didn't just stop. When Juno gets there, it's not going to measure the exact same things that were there in 1972. We know for a fact things will have changed. We haven't had an observer out there monitoring Io for every single thing. Even the resolution of our cameras, 1 pixel, I don't know whether it represents a mile, a kilometer, however sensitive the camera is, does not pick up on all those chemical reactions. And chemical reactions are reactions change over time. Time is essential to explain why when you flick a match, it becomes a flame. Now, I understand if you remove time and present it as an illusion, the variables become easier to work with. Some equations only work when you remove certain measurable quantities. And scientists are very upfront with that in their papers. They say, okay, for this we are we're reducing whatever variable to zero because it's hard to measure, it's unpredictable, whatever it might be, and it might skew the results of this experiment. They write it up in their papers. That's not bad science. That's performing a measurement and beginning to do good science. If you have your basic forces of the universe, your gravitation, your strong nuclear force, your weak nuclear force. I forget the fourth one, although I believe it's electromagnetism. There might be a fifth force out there. It's long been an idle thought of mine that there has to be something outside the electromagnetic spectrum, and maybe that's why we get reports of UFOs, AEPs, whatever you want to call them, defying our laws of physics. Excuse me. Because humans are very good with the electromagnetic spectrum. Time drags us along in our everyday lives. Now, from a fatalistic viewpoint, you could say that's moving us towards whatever destiny we have. I'm sure you know Silverlight does not believe in destiny. Just most people are generally good and orderly and want to have a good society around them, and they make decisions to effect the same. Time, essentially the idea that time doesn't exist boils down to all events are happening at the same instance. We're just slightly shifted away from each other, almost as if you shifted to another dimension. And you're traveling through these dimensions. That's the idea. All time is happening at once. But for that to be true, there has to be time. Some force dragging you along, making sure that you can't go up to Queen Victoria and shake her hand. Not that she would allow a peasant like you or I to shake her hand, but that's the idea behind the time is an illusion. Yet every measurement possible, even down to the smallest things we have, I don't think we're at the Planck length yet, but at the same token, there's definitely a lot of measurements going on at the same time, and they're all affected by this mysterious force known as time. We're at a very interesting point in physics. We mastered the basics. We'd be like a grade 10 student. You know, we know the basics. We have a few formulas. We haven't quite graduated to the point where they can start teaching us the really cool stuff. But at the same token, we can do a heck of a lot. Some things that even our parents can't do. And it's natural for us to wonder, hey, what if? Because again, grade 10s are very curious about things. They want to find out, well, they will run a simulation, also known as a video game. And the video games these days, even Roblox, they can do some amazing things on them. And yes, I know there's people out there, oh, Roblox is just a game for kids and blah, blah, blah. Maybe it is. But it's a very educational game for children. And while we begrudge the time that they spend on it, the fact is it's attractive enough for them to use their time. We're not constantly switching dimensions to a new possibility. Time exists. Now, once again, I understand for mathematical and philosophical reasons, it's easier to eliminate time because while we know how to measure it, we really can't influence it. I can't take you and bring you back to when you were 10 years old and the bullies were picking on you and tell them, hey, stop. No, we can't do that. And even so, I'm not sure it would be a good idea. I've enjoyed several fantasies in my life where I change something in my past, and every single one comes out with a bad outcome. They keep saying it's impossible to do time travel, and even if it was possible, you could only go back to the point where the machine was created. I don't understand the physics behind that, but it does make sense to me. If the machine doesn't exist, then you can't go back further in time than where it began. It's not like one of these wormholes or Doctor Who and vortex manipulators and TARDISes and whatever it is. It's it's going to be a machine that uses probably extreme electromagnetic force to literally bend time and space to create some sort of a wormhole. Probably going to be the first time machine. So when you're listening to this in 3025, yep, you got the idea from me. And whoever was working on it, hope you were successful. Basically, what this means is humans are, like I said, basically a grade 10. You're nowhere close to a university or college level, but we do have a basic understanding. And that's why we need people like Neil deGrasse Tyson, the, the professor formerly known as Stephen Hawking. We need these people to be asking the big questions at the extreme ends of space and time. Because without them, we're not going to be able to figure out the miniature details and the proofs and the theories we need to actually address the bigger picture. Our version of time is incomplete. Our version of physics seems to be incomplete, as there's still some things we don't have the answer to. And we need to keep studying it. And as I said, I can appreciate knowing that you have to simplify an equation to make it work. E equals mc squared is very useful, but it doesn't really apply to your picking up groceries. You can extrapolate from it and figure out an equation, or at least I can for the people I'm familiar with because I know their shopping patterns, so I can model that as an equation. But it's really time consuming for such an insignificant action. The same is true for, LIGO, the gravitational detector. It needs massive collisions over time just so that we can figure out what's going on with the gravitational force. But we can only do that given enough time. So with that, we hope you had an interesting exploration of time in the limited amount of time that we had. We hope you enjoyed this episode of the Silverlight Show. If you did, please like, share, because sharing is caring. Subscribe if you haven't subscribed already. Don't forget to click the notification bell icon, whatever you want to call it, down below, so you can be updated every time we publish a new show, which is usually every day about noon, but I fall behind sometimes. And we hope you have a fantastic day.